We are working on the POC of a smart factory setup, and the smart factory works on the concept wherein we would be capturing the customer these configurations or the requirements as a smart product identifier, and it has the mechanism to read the customer specification. We have also the MES system, which would be capturing the available configurations of the customer, which can be delivered, and these sensors would be talking to the MES system. MES would be again driving or sending out messages to the assembly line, so that the assembly would be created in as per the product ID. And also in this smart factory, we have also implemented the smart Kanban, wherein the inventory level would be monitored on a continuous basis, and as soon as the inventory level comes down than the threshold, then it would trigger the material handling equipments. And also once the material handling equipments are moving, we have also implemented the factory safety, that if any of the material handling equipments come across the obstacles, they would act accordingly, stop or take appropriate actions.
One question before we go further. So what is this JAS 1.6 and Incola 1.1?
So these are your variants. Okay. So what we have implemented is a mobile application. So on that mobile application, we have provided various options to customer. So instead of providing the configuration to customer directly, we have provided options. On the basis of manufacturing ID, we will just segregate our customer specific order, and we will communicate that much info to our workstation. We call it as an engine assembly. So workstation, we will take a decision or runtime on the basis of our variants, and we move according to that particular bin. In our case, it is the Incola 1.1 and JAS 1.6.
Okay. So let's start with the demo then.
Yeah.
So this is order identification ID, which is going to be used for identifying which order is placed. And this we are having dummy changes, or maybe we had tried to mimic the changes. Okay, so this is what our conveyor belt is. We can see the moving assembly line, and on that we are placing the dummy change along with the product identification. And this was the specification for our Incola engine. Now it has picked the product from the inventory or bin, and it's got placed on the changes. We will demonstrate the movement of our stacker as well, which will bring the inventory. So just I'm proceeding with, like, if it goes beyond certain limit, if our inventory goes beyond certain limit, then stacker will bring the perfect product from there. See, the stacker has got the fresh product. Whenever the stacker moves and if it finds some obstacle in between, so from the safety point of view, the stacker will start and it will give the instruction that on the dashboard, and then when the sticker moves, it moves further. Yeah, so now it is stopped, and whenever the obstacles will get away from his path, then we move further.
Okay, so is this the dashboard for your smart factory?
Yeah, this is the dashboard that we have developed for the smart factory system. So as you can see, we are capturing the total assembling time, then the inventory status, as well as the status of the stacker. So the assembling time, it basically tells us how much time did the robot arm took to assemble one part. So suppose it takes 20 seconds, then we'll see the figure 20 here. So accordingly this pie graph will be updated. This inventory level, it's a graph which shows the level of inventory currently in the inventory system. So basically it will, as the inventory level goes down, we can see this graph goes down, and as the inventory level goes up, we can see the again graph going up. So that way we can keep a track of the inventory. And this stacker, it indicates the status of the stacker, whether it is running or it's in parked state, or whether if there is some obstacle in between. So initially it's in the parked state, then whenever it gets a signal to run, then it indicates that it's running. It's currently in the running state. So and when it reaches the destination, it again moves to the parked state. Now we have added a safety mechanism in it by which if there's an obstacle in between, then the truck stops and it flashes a red symbol saying that I'm stuck. So if there's an obstacle in between, it will indicate that it's stuck, and then when the obstacle is removed, then the stacker will again resume running and it will show us for how much time it was stuck. So that way we can identify what was the safety issue that had happened and how much time it took to resolve it.
It is never fixed that in configurable plant structures, it is never fixed how much products are getting out from the plant every day. So this is the graph we are showing for every day. Okay, so let's say on first day it is getting an output of 10 products a day. So it has increased second day because customer had demanded more products. Okay, so this is the production and this is temperature.
Okay, so during Techathon, we were only focused like we have to do something new using IoT.
Actually, it took a little or much longer.
Correct.
In the end, we were able to apply our core area of PLM and manufacturing domain knowledge, couple it with the cutting edge technology, and make those machines talk to each other, talk to the system, and the smart factory prototype was done.
So that's how Smart Factory works, machine to machine communication.
So this was a great learning experience and we enjoyed a lot
Yeah.
while working on this project.
That was the best part.
Yeah, smart factory rocks.
Yes.